So tonight we're going to talk about parabolas, and parabolas can be written in two forms. Parabolas can be written in standard form, and standard form is always going to be ax squared plus bx plus c. And standard form is very useful for finding the y-intercept and the zeros. And if you recall from algebra, the zeros are the same as the x-intercepts, and they get their name from the zeros occur when y is equal to 0. So that's how we find them. We set y, or f of x, equal to 0. And we'll do that in a little while. They can also be put in vertex form. Vertex form looks like this from algebra. F of x equals a, which is your vertical stretch or shrink factor, x minus h squared, and h is your horizontal shift, plus k, which is your vertical shift. And this is called vertex form because it's very useful for finding the vertex. And in real life, in an application, the vertex would be where the maximum or the minimum occurs. Okay, so the maximum or the minimum. It's also very useful for sketching the graph, knowing what the graph looks like, because from the vertex, you know if this thing's pointing up or down. And if you recall from algebra, a positive a value is an upward facing parabola, and a negative a value is a downward facing parabola. Okay, so we've been asked to find the standard form of a parabola that's in vertex form, and so we want to go through that. So how do we find standard form of a parabola if it's in vertex form? Okay, so here we've been given a parabola in vertex form. We want to convert it to standard form. To convert this to standard form, all we're going to do is expand this term here and then combine like terms. Okay, so to expand this term, recall that x plus 3 squared is x plus 3 times x plus 3. And if you remember, there's a special multiplication for that. This is called a perfect square trinomial. And if you remember that, you can use it. And if you don't, you're going to multiply every term. So x times x will give you x squared. And then we get 3x, and we get another 3x. So we get a total of 6x. And then 3 times 3 is 9. If you recall the FOIL method, this is the first, this is the last, and this is the outer plus the inner. Okay? So first, last, and outer plus inner. Okay, so we know that that's x squared plus 6x plus 9. So that is going to go in place of this part right here. Okay, so we get y equals 2x squared plus 6x plus 9. Right, so that becomes that plus 5. So then what? Distribute the 2. So we get 2x squared plus 12x plus 18. So all of that becomes that, and then copy that plus 5, and then combine that final 18 plus 5, and you get a final answer of 2x squared plus 12x plus 23. And there is your parabola in standard form. So to convert to standard form, all we're going to do is multiply and then combine like terms. Okay? Multiply and then combine like terms. Okay? That's all you got to do. Anytime you're asked to convert to standard form, you're going to multiply any square terms out and then combine like terms. Okay? So now you know how we do things in math. If you're going to go one way, you got to go the other. So now we've been given a parabola in standard form, and they want us to put it in vertex form. And to do this, to convert to vertex form, we must complete the square. And this is something you should know how to do from your algebra class. To convert from vertex form, we must complete the square. This is a process you should know from algebra. Okay, and this is typically covered in trigonometry, but I'll give you a little reminder. So I'm going to go through the process here. There's a 4-step process to completing the square. Okay, so when we look at this, you think of an A term. This is your A term, your B term, and your C term. Okay, and the first step to completing the square is you have to make your A term equal to 1. You have to make your A term equal to 1. And the way we're going to do that, and what I like to do is I like to show my math and then write my results in a different color. So I'm going to show my math in green and write my results in blue. We're going to divide everything in this entire equation, including the y value. That's the big one. Everybody always forgets that. We're going to divide by 4. Okay? So I end up with y over 4 equals x squared. Now 20 over 4, that's going to be 5. No big deal. And 10 over 4, well, that doesn't go evenly. We'll just keep it as an improper fraction. So 10 over 4 is going to reduce to 5 halves. Okay? So that's our first step. Our second step is we want to get this constant term on the other side. And the reason for that is that we're going to take this polynomial that does not factor, and we're going to create a new constant term that forces it to factor. Okay? So we're going to move that 5 halves over. So that's really easy. We get y over 4 minus 5 halves, right? Because we subtract that from both sides. And that's equal. And this space is very intentional. So leave a little space on your paper there. There's a reason for it. That's equal to x squared plus 5x. Now, when we cover this in algebra, I explain this in a little more detail. But if you remember these old perfect square trinomials, very much like this first example, right? X plus 3 times x plus 3, or x plus 3 squared, right? They looked like this. It was a squared minus 2ab plus b squared. Or it could be a squared plus 2ab plus b squared. Okay? Actually, I'll use the plus since that matches the equation we're working with. So, since a is 1, this is really just 2b. This here is just 2b. Well, if I divide this by 2, and this is the same every time, divide this by 2, and you're going to get 5 halves. Okay? That's equal to the letter b. Well, I want b squared. And to get that, I'm going to square it. And what this looks like if you're not watching what's in green is I've got x squared plus 5x, and I decide to randomly add 25 fourths to that. Okay? Just randomly, I'm going to just add this magic number to the right-hand side. Well, I can do that as long as I add it to the left-hand side. Okay? So that space I left earlier was very intentional, 25 fourths. Okay? Now, here's the fun part. We're going to combine these two terms. So this is the same as 10 over 4, right? As a matter of fact, we reduced it from that earlier. 10 over 4 plus 25 over 4, and we get y over 4. Actually, it's going to be negative 10 over 4 plus 25 over 4. So negative 10 plus 25 is going to be 15 fourths equals. And now you want to take this polynomial right here that you just came up with. And this is a perfect square trinomial. A squared plus 2ab plus b squared. And we're going to factor it. We're going to factor it. And it factors into a plus b, quantity squared. So it's going to factor into x plus 5 halves squared. Okay? So now if you recall your vertex form, right, x plus h or x minus h quantity squared, we need to get our a term here and we need to get our k term, our vertical shift, here. Well, if I move this over and put it here, it becomes that k term. So let's do that. So we end up with y over 4 is equal to x plus 5 halves quantity squared minus 15/4. Okay, so now we've got our h, we've got our k. I need to solve for y, so I'm going to multiply by 4. So I come in, I'll use a different color ink here. We're going to multiply by 4, multiply by 4, and multiply by 4. Multiply every term by 4. And we end up with y equals 4 x plus 5/2 squared minus 15. This is vertex form. And from this form, right, A is positive, so we know this parabola points up, and it has a minimum. And that minimum, right, this means it has been shifted to the left 5/2 and down 15, okay? Left 5/2. Anytime you have something grouped with your x, it's going to do the opposite of what you think. You think plus 5/2 is to the right, it's going to be backwards. And then this, of course, does exactly what it says, minus 15. Okay? So, our vertex, normally we start at 0, 0, the origin. So our vertex will be negative 5/2 right to the left, comma, negative 15. So if you wanted your vertex, that's how you find your vertex. Okay? So hopefully this is helpful, converting to standard form and converting to vertex form for parabola. I'll have another video shortly after this talking about the parts of the parabola, and you can watch that, and perhaps it'll help you with some of your conic sections in trigonometry.